Okay, good afternoon. Thanks everyone for coming. I realise it's the end of a long day, so thanks for sticking around. This section is called Triskaidekaphobia, which is the fear of the number 13. The significance of which is we're going to be covering looking at Windows Phone 7 development from the perspective of someone who's been developing with Windows Mobile 6. Okay, so I've made two assumptions really for this session. The first of which is that you'll have a basic understanding of Silverlight development on the phone. You'll have probably attended, there was two sessions this morning walking through the whole experience of developing for the phone, and if you haven't seen those, they will be available online as well. The second assumption is that you'll have experience of developing for Windows Mobile 6 or similar, so that includes some of the Windows embedded platforms, and in Windows Mobile 5 as well. There's very, very similar really. So I'm just going to refer to those all as 6, just for simplicity. Okay, so the agenda today is to look at a couple of big issues first and get those out of the way, and then walk through aspects of the application itself, some of the UI, and components that are kind of reusable for your application, and then we'll look at some of the ways that your code can interact with things outside of the device, so a bit of location and networking, that sort of thing. Okay, so the first thing up, here are the big changes from going from a compact framework development through to Silverlight development on Windows Phone. So the big ones are, if you're used to doing sort of low-level code, p-invoking down to system functions, and interoperating with COM components like Pocket Outlook and those sort of things, or actually writing in Visual Basic, these are currently not supported. So all development on Windows Phone is currently C# only. The next major thing is there is no system data namespace and there's no SQL Server compact database, so you've got to find an alternative way of accessing your data and persisting it. Okay, another one refers to interacting with external hardware, so there's no serial ports, no Bluetooth, and so no access to external sensors, printers, barcode scanners, those kind of things. The devices all have Bluetooth, but it's used purely to support headsets and audio devices. And finally, clearing up a few other bits, there's no direct access to the file system. Your application has an isolated store, which is just a small area that's private, that no other applications can access, so it's entirely up to you what you do with it. There is a registry on the device, but it's purely used by the system, so you can't store your settings there. But again, you can use your isolated storage to put whatever you want. There's no direct access to Pocket Outlook, so your calendar, your contacts and tasks and those sort of things. You have no access to those directly, although there are a couple of components we'll look at later which allow you to do basic things with contacts on the phone. And finally, one of the features that was in Windows Mobile 5 and 6 was the system state functionality, which gave you a whole load of properties that you could query, and you could actually hook on to events as well, things like changes in networking availability, currently running application, the user's name, date and time, all those sort of things. So none of that has been moved across, although there are a few things to do with networking that you will be able to use. And another thing, of course, is getting used to a whole new model of UI. So Silverlight brings a new set of tools and a new way of actually building forms. It's all based on XAML, which is an XML format, so it's completely different to the way that Windows Forms works, although actually the tools make it just as easy to do drag and drop, put your components on and build a page from that. Another item which is new is there's a push notifications mechanism. So built into the phone, you have a mechanism to send updates to the phone from the internet. So if you want to do like timed updates or when things change on a server system, you don't have to write a lot of plumbing to actually get your device to connect to the server and check for updates. It's pushed down as and when things happen. And finally, with Windows Mobile 6, you could actually distribute your applications via the marketplace, or you could host them on your own website or via a third-party shop like Handango or similar, or even just send someone the files in an email or FTP them. Here you can only distribute your applications via the marketplace, which is fine for consumer applications, but obviously when you're building something for rolling out within an enterprise, it's a bit more tricky. So now we'll go into components to build up your applications, so like UI controls and those sort of things, and what's changed. So a whole load of controls that existed in Windows Forms have a direct comparison in Silverlight. Some of the names have changed, but functionality-wise, they're pretty much the same. The main thing to notice is that previously there was a list box, a list view, and a data grid control. In Silverlight, there's just a list box, but it's completely controlled by templates so that you can decide whether each item is a single string or whether it has an image and a text or multiple lines, anything you want, really. And, of course, it's data bindable, whereas previously the list view control, which gave you an image and text layout, for example, you couldn't data bind to it, so you'd have to manually go through your data and then add items to it. There are a number of controls that, at least in this version, are not available, which you might have been used to. So combo box, context menu, datetime pickers, and those sort of things. You can create most of these yourself as custom controls, or I suspect there'll be third parties who come along and fill in some of those gaps as well. And so finally, there's a number of controls which have kind of an indirect substitute. So previously, when you would stick individual scroll bars onto a page and then hook up events onto them and move things around, you now have a really useful controller which is called the scroll viewer, which is basically kind of a TARDIS control. So you can put more inside it than the outside size would let you have, and then it will also automatically handle the scrolling for you. And actually on the phone, it handles touch gestures as well, so it'll handle your scrolling just by flicking the finger across the screen. The sort of toast notification that existed on Windows Mobile, there isn't a direct comparison to that, but you can either use push notifications to pop up messages when your application is not running. So if you have a notification from your server, it'll bring up a notification on the top of the screen, which you can then tap and run your application. Or if your application is running and you want to display a timely notification, you can use the pop-up control and basically bring up something in front of your main form. You would use the panel control with Compact Framework to lay controls out, and there are actually 3 controls which replace that, which have different behaviors, and we'll go into those in a bit more detail in a second. There's no direct comparison for the tab control, although there is a panorama control which creates an application which looks a bit like some of the built-in hubs. So, for example, the People Hub and those sort of things, where you have separate columns or pages that you can slide between. So it gives the impression of being a very large layout, but actually it's subdivided into separate sections, so you can only view a small part of it at any point in time. The timer, which you might have used before in Windows Forms, there are 2 options really that replace that. There's a dispatcher timer, which is used in code, so you can have things happen on events from a dispatcher timer, and that occurs on the UI thread. Or you can set up storyboards to actually create animations and things on your forms as you transition from different states. And actually the expression blend tools give you an easy way of building those up. And finally, the main menu and toolbar controls don't exist anymore, and Windows Phone has a new application bar, and we'll go into that as well later. So now we're going to jump into some code, look at a very simple Windows Mobile 6 application, and then look at the Windows Phone 7 version of that same application. So I'll run the demo first in the emulator, and then I'll walk through the code and just show you what it does. It's quite simple. So the application uses a typed data set to store the data, and it's just a collection of smartphones. So what it does is, as it loads from an XML file into the data set, and then it will populate a list view control, which is all done manually, of course, because there's no data binding in list view control. And then there is a sub-page for each item as well. So when you tap on a particular item, it'll then open up a separate form as a dialog, and then that shows, again, the details that exist in the data set. There's no navigation for the unit, so you press the OK button to dismiss the dialog, and then you're back at the main screen again. So you can see what happens when the form loads up. We mark the list view with begin update, which tells it to not do any UI updates while we're populating the data, because otherwise it creates sort of flicker and slows down the whole process. Then we create a single column for the list view. because even though we're not showing the header, if you don't have a column there, it won't actually show the data that's within it. And then in a separate thread, we run the load data method. So this basically looks for the XML file, and then when it's found it, it'll load it into the mobile phones, which is our custom data set here. And then we simply iterate through each row in the mobile phone table. We load up the image, which is basically stored as a file name. So we create a new bitmap object from that file name. We add it into an image list, and then we create a new list view item for each individual phone in there. And then that list view item is then added back into the list view on the UI thread again, which is a simple method which just simply wraps that, and that's invoked, so it runs under the UI. Once all that's finished, we simply call end update, which makes the list view then available to use because we've finished populating it, and take away the spinning wait cursor. The only other thing that really happens here is when the user clicks, causes the item activate event, we create a new instance of detail form, and we pass into that the ID of the phone, so that in the detail form you can then load up the record that's specific to what it was selected. So this is loaded up as a dialog, so you can pass in this form as the owner so that it doesn't show up as a separate thing in the tasks list. And then we call show dialog, so basically we can't go back to the previous page until we've dismissed this one. So we now switch over to the Windows Phone 7 version. It's a very similar thing. We have an application which it's based on one of the built-in templates. So there's a template for a Windows Phone list view control, so list view application, sorry, and it basically builds the skeleton of this for you. We've customized it slightly here because we've changed it to actually persist the data to a file, because normally it's actually loaded through code. And also, rather than just having a generic image next to each item, we've actually loaded the photo of the phone next to each item, and then so as we click on any particular item, it causes a navigation event to a separate page, which again contains the details on that particular phone. So the XAML for the main page, basically, this was all created by the template, so it's quite straightforward. There's basically an overall grid which defines the top bar, which has the sort of headers in, and then the rest of the content. And then, so within that is a where are we? No, I've got the wrong one here. It doesn't help having two projects with the same file name within them. So the design is a bit screwy here, but if you look at the XAML, there's a list box, and all we've done in that is create a template. So this is basically applied to every object that exists within the list box. And that gives you an image, which we've set the size of as well, so that they're all the same height, which has a data binding to image URI, which exists on our data source, which we'll just look at in a second. And then there's two text objects, which are stacked. So we have a main, the model name, and then underneath that we put the manufacturer. This is a completely different way of storing the data than was in the 6 version. So basically we have a type which defines the phone, and that has a number of properties on it. So we have manufacturer, model, and an image URI, which describes where the photo is stored. And obviously there's an ID code as well. These all implement the iNotify property changed interface. So we have an event on there which gets fired anytime you change a property on that phone. So for data binding, the UI can update automatically if one of the properties changes to elsewhere in code. So then there's the main view model, which basically has a collection within it, which you can see is an observable collection of the phone view model type. And we've added the extra stuff in here, which isn't in the original sample. So we've added a serializer, which is a data contract serializer. And this is a type which can basically take any type that you've described and serialize it to XML and back again. And because our type contains it's all serializable.
And I'm going to call this one top navigation.
Okay, I'm hearing voices.
I'm going to use one of the built-in templates. Now, Umbrico ships with this list.
We have a method here called load data, and what that basically does is it loads a file from isolated storage if it's available. So we check that the file exists in our application's isolated storage.
And manually configure it.
And then we pass it to the
okay. So what this has done is it's created us an XSLT
with read object. And then we call notify property changed phones, which actually tells the UI that the collection of phones has changed, and so it will create the list. And so that's all that happens there, and it happens with the isolated storage file stream. If that doesn't exist, then I've actually embedded an XML file within the package as well, which contains the initial selection of phones. So the same code here, but it's actually loading from an embedded resource rather than from an isolated storage file. And actually within the sample code as well, there's a save method. So when the application is closed down, we can actually take all of that data in our view model and persist it to isolated storage to use again. The details page is pretty much the same as the sample again. Unfortunately, the design is not quite working properly. The thing we've added in is actually an image, which is a control, a bit like a picture box, which is now bound to the image URI on our object. So we've got a bit of text and a bit of an image, which is based on that, whichever record was selected. Because we've used the data contract serializer to create this XML file, it's slightly different to the XML file that's created from a data set, which even has the same fields in it. So the external element is actually array of phone view model. But it's actually very easy, if you've got this data in this format, to do some simple replace to go from...
So we've got our macro in there, it's put in the Umbrico macro.
To go from the alias version or vice versa. And in fact, if you didn't use the data contract serializer but wrote your own...
we now have a navigation that
you could actually use a single XML file and use it on both applications. So we now look at the controls available to do layout on the phones. On Windows Mobile 6, you had basically a panel control, which you could put any control into with coordinate positioning. And later on, the docking and anchoring properties were added with .NET Compact Framework 2, which gave you some ability to make dynamic layouts. So when the screen size changed, you could make controls which would fill like the top or the bottom sections of the screen automatically. So with Windows Phone 7, you have 3 different controls that can do positioning. There's the canvas control, which works in a similar way. You can basically put any control in it, and it's defined by its top and left properties. Secondly, you have the stack panel control, which basically, as you add controls to it, they are placed in it sequentially, and it can either operate horizontally or vertically, and it'll account for whatever other controls have been added in there, so everything's kind of spaced correctly. And it'll grow as you add controls to it. And the last one is the grid, which allows you to set up a definition of like rows and columns, and you can actually have items which are then either assigned to a single row and column, or you can actually have ones that span multiple columns, so you can create quite complicated layouts using the grid control. So I'll go back to a different piece of code. So we basically see we've got in this example there's a grid which has a number of buttons and things in it. Then we have a stack panel which again has text boxes and buttons in it, and then finally a canvas. So if we just see this application running, you'll see how they behave on the phone. So basically the top piece here is a grid, and there are a few cells which are not currently used, so there's a big space here. But basically you can see everything is laid out and sized according to the same row heights and column widths for the grid. And then below that you can see we have a stack panel. So we have a number of buttons that were just added, and they automatically fill the width, and then they're stacked on top of each other. And there's some text boxes in between which are empty, so that's why there's some gaps. And then finally the canvas, we can just drop things anywhere in it, and they will appear at the location that was specified. So we talked a bit about having pop-up notifications, because the notification control we had in Windows Mobile 6 doesn't exist, but there are alternative ways of doing it. So basically, there is a message box control, which is very similar to what you had in .NET Complex Framework. It supports the OK or OK cancel responses, and it's all styled to look like the phone. But if you want to have more options, you want to change the text in the buttons, it's quite easy to use the pop-up control and actually create your own pop-up dialog. And if you read the document, I've got a link at the very end, of design templates, it actually gives you what are the expected layouts for these sort of pop-up dialogues so that they actually fit with the Windows Phone theme. So as an example here, it looks a bit like a message box, but we've got some custom text and a header, and we've named the button Dismiss instead. So we go into the code for that. Okay, so I've basically rigged up to this button here. So as I press the button, we're using the pop-up control here to show our custom notification. As you can see, the color is matched with so if a system notification came up, it would be the same color and layout as this. So when you're in, for example, programs that will prompt you in saying, right, the battery's low or something, it'll have a similar style. And the other thing you can see, which is, again, like the system, is that it actually grays out, or it's semi-transparent, the background here. So you can't actually touch buttons in your application and go back and do anything. And also, you can either hit the dismiss button, or you can tap the back button on the hardware, and it will dismiss the dialog, and it won't actually go back, it won't navigate back on the actual application itself. So we go back to the code for that.
Prompt ends.
So what we do when the button's clicked, we create a new notification dialog, which is actually a user control, which has everything in it that we want to display. We've set a property on that, which is, so we just said something important has happened. And then we use the built-in type, which is the pop-up type. And we basically, there's a few extra bits there. We've decided that when this pops up, we want to hide the system tray if it's currently showing. And also if the application bar is visible, we'll hide that as well, because you can't use it while the actual pop-up's in place. A few other bits we have to do to make the navigation work is we hook up a handler to the closed event on the pop-up. So when the pop-up is dismissed, we'll get a notification back and we can tidy up the UI afterwards. We also hook the form or the page's back key press event so that we can override this, because we don't want to actually navigate back from that application page to wherever it was before. We actually just want to use it to dismiss the dialog. So then all we do on the pop-up control is we set the child property to the user control, which we've created, and I'll just flick to that in a second. And then we set the isOpen property to true, and that's what actually shows the dialog. So you can see here that the notification dialog is actually full screen. The main background is painted in a 50% transparent brush. So whatever is behind it will be partially hidden, and that'll cause it to be won't be tappable. So you can't tap buttons and things that are behind it, but you'll still be able to see your application visible behind. And we basically, everything's hard-coded here on this example except for the text block in the middle, but you could actually have one that you customize the title, you could have different buttons. Again, as long as you're sticking within the sort of style of Windows Phone. So the code for that is basically, it inherits from user control, and we just basically have a handler here to handle the dismiss button. Because the user control itself isn't the pop-up, we have to get the parent control, which we know is a pop-up. So we use the parent property, but we cast it back to the type of pop-up. So we've got a reference to that, and then we can call the isOpen false, which will cause the pop-up then to be dismissed. And the other thing here, of course, is we expose notification title as a public property so that we could change that and notification text, so we can change that from outside of this control. So back into the main pages control. When the back key is pressed, we check if the pop-up is actually in use. So if the pop-up is not null and it's currently open, we call isOpen equals false, and that will dismiss the dialog. We then unhook this handler because you don't want it to fire again until we next register the pop-up control. And we also set the cancel equals true property, which means that the back event isn't passed back to the OS. And the other bit of code that will then run is the closed event on the pop-up. So our handler for that turns the system tray back on again, and if the application bar exists but it was hidden, then we just make it visible again. Okay, so another main difference between Windows Mobile 6 and 7 is that the menu has been replaced by the application bar. So previously we were used to having two menu items. So the left one's usually reserved for a primary action, like creating a new record or something. And the right one could either be a secondary action or could actually open a pop-up menu with lots more options on it. There are a few extra things you could do. You could have dividers, so you could actually have your menu split up into different sections. And also checkboxes on items as well, so you could have a feature which was enabled or disabled via the menu. On the 7, you basically get 4 icons, so you can have all your sort of current actions as icons with a small text description below them. And you can have also up to 5 menu items which are just plain text. So those are simple actions, so you can tap them and they'll do something. They don't have checkboxes for enabled and disabled, but you can easily work around that by simply changing the text depending on the state of the setting or whatever. And the other good thing about it is that you only have to define your icons once, and the system will actually apply whatever theme is currently set on the device for you. So the default in the designer is with a dark background with white text. So you supply an icon which has white on a transparent background, and whatever colors you set on the actual thing at runtime, your images will actually be changed to match that. So I can just quickly switch back. So back up at the top of the application, we've got a button here called Application Bar. So through code, that changes the foreground color. You can see it's changed to a kind of reddy color. And actually, the icons have changed as well as all the text. That's kind of free functionality that's built in. So basically, there's a little pop-up there of what the menus actually look like, and depending on the theme. Okay, so all the colours and brushes and fonts that are used within the sort of Metro style are stored as resources which you can use within your applications. So all the standard controls, use these automatically. So if you drop a button onto a form, you know it'll be painted with white on a black background, or vice versa. But if you're creating some kind of custom control, you can use the brushes and colours that are already there, so that your app instantly follows the same theme. If you want to add your own, you can add them into your app XAML, and they'll be visible across any page within your project, so you don't have to hard code them in different places. So a simple example of that is within the app XAML, we've added a color brush there with a specific RGB value, and then anywhere in your code you can simply refer to that using a static resource. So here we've set the foreground for a button to a particular shade of blue, and again you've done that once, then you can use it anywhere. So when you talk about themes on Windows Mobile 6, really you had very limited options. You had system colors, which had a number of standard Windows colors, including whatever the highlight color was and things like that. If you wanted to get the user-selected font size, which could be anywhere from very, very small to very, very large, then you actually had to p-invoke into a system function, so it's not particularly useful, and most people didn't bother doing that. You stuck with the sort of hard-coded font sizes that were in the Windows Forms templates. The one thing you could kind of rely on was that your dialogues would always be black text on a white background, and you have to do a hell of a lot of work if you wanted anything different to that, if you wanted to have image backgrounds and things, because none of the controls support transparency. So you basically have to rely on third-party controls to do that kind of thing. So on 7, the way that themes work is very different. There are two two main themes. So you basically got dark, which is a black background, or light with a white background. But then you have a number of accent colours, and the phone has 10 on it as standard, but the device OEM can actually add an additional one. So if they have a corporate colour, they can sneak in an 11th colour there as well. You don't really have to worry about this, because if you use the standard brushes and things, you're giving up whatever that is currently set on the device. But you do need to make sure you test on both dark and light applications settings, because you might find that your application looks fine on one, and actually when you look at it on another, it doesn't work for whatever reason. The other thing to do is to avoid overlaying the accent colour over coloured elements like an image or something on your form, because that colour could change depending on the user's preference. It might be visible against certain coloured backgrounds but not on others. So although it's fine to have that over a white or a black background, you might find troubles if you have, for example, a picture of something green, and then the user selected a green accent colour and suddenly it's invisible. So this is a bit of code. This actually doesn't work on the current beta release. This is going to be in there for the final. So there's a new resource added, which is called phone light theme visibility. So basically you can check that value, and if it's visible, then you know you're on the light background. So you can actually change properties within your form depending on that. The main reason you might want to do that is to change a background image, because obviously if you're using standard colours for background, that's dealt with for you. But if you have a very dark image, which would work great if your text is currently white, it might look terrible if you then have black text on that background. So the code sample here changes the background, and it's actually of a panorama control, which isn't in the current tools, by loading an alternative background from code. Now it is possible to do this on the beta release as well, but the code is slightly different, so I'll just switch to that. So basically, the difference here is we get the phone background colour, and we actually just check the RGB value. So if the R is greater than 0, we know we're on that the background is white. So we could then assume that we're on the light resources, so we can change the background image to a different brush. So we've actually set up both here for for the dark or light, and then we'll just switch between them when the page is created. So if we looked at the example we had here, it has a very pale background on it, but if I go back out and change the theme, so you can see we've changed the background image now to a darker blue, and obviously the white text on top of it looks okay. So in terms of laying out your form components, basically on Windows Mobile 6, all your devices had a resistive screen, with a couple of exceptions. There were some, the more recent devices had capacitive screen, but they're really in the minority. And because all the devices had a stylus with them, you always had that to fall back on when you had tiny little checkboxes and things that you had to try and tap. Whereas on Windows Phone 7, all devices have a capacitive screen, which means you have to be able to touch things with the squishy bits of your fingers. So you have to think about not trying to pack too much onto the screen at any time. And actually, if you follow the sort of standards of the built-in applications, that's what you'll notice. There's lots of large fonts. Things are nice and big, and you can drag them around with your fingers. And basically, if you're going forward doing projects on both 6 and 7, you should really apply similar rules, because tends to be the case that the applications built like that are much easier to use with one hand, for example, even on like the older devices, than some of the applications that were written purely for a stylus-based input. So if we look at navigation between pages or forms, this is something that's kind of new to Compact Framework developers, because on the Compact Framework you created a form, and if you wanted to then move to another form, you created a new instance of that form and called the show method on it. If you actually wanted to do anything more complicated than that, like have some kind of long stream of navigation between pages and then be able to go back over things you've done, you had to write a lot of your own code to keep that kind of stack and to know what position you're in and do all the navigation for you. The model in Silverlight is completely different. It's much more like the web. So every time you go from one page to another, It's a navigation based on a particular URI. The runtime maintains the history for you, so at any point in time you can see if you can go back or forwards, and you can navigate back, forwards, or to a URI, which will basically be your XAML file, and optionally you can pass parameters as well at the end of that. All devices have a hardware back button, which is tied directly into this, so the user will always have the option of going back to previous forms, or if it's the first form in your application, it'll actually exit your application and go back to the shell. Because the model is very different, your UI components are bound to your view model classes in the background, so as you progress between forms, the settings will be written to your view model, so as you move on, you've got whatever was set in the previous form, so you can access it via that method. So now we'll look at some of the kind of tasks and reusable components that are in the system. So if we compare version 6 to version 7, on Windows Mobile 6 you had a number of different namespaces which had components of various different aspects of the system, whereas on Windows Phone 7 everything's in the Microsoft Phone.tasks namespace. So the first thing up is you have camera capture as before. Another thing that's very different is how contacts are handled. So you don't actually have access to the contact and all its properties. You have two very specific tasks. So one will allow you to choose an email address, and one will allow you to choose a phone number. Likewise, for the messaging application, before you had a display compose form method, which you could actually use to start creating an email, an MMS message, or an SMS message. Windows Phone 7, you have two specific tasks. So you have email compose task and SMS compose task. In the telephony namespace, you had a phone object which had a single method called talk. And again, this has now been moved to this sort of task model, so you now have a phone call task. And the ability to select picture. You have the select picture dialog, and here you've got the photo chooser task. And the way that Windows Phone 7 works is there isn't a file system in the same way, so photos are a whole application in themselves. So the photo chooser tasks will display everything that's in that photos hub that you'd see as a user. So they all follow a very basic system for how the code fits together. You basically create a new instance of the task. You hook up the completed event so that you know what's happened when it comes back to your application, and then you call the show method. So in the example of the camera capture or photo chooser tasks, you get a photo result back. One of the properties of this is the original file name. Now what you can't do here, because you don't have access to the file system, is actually use that to open up a file stream to that file. Instead, you've got the chosen photo property, which is a stream, so that you can actually load that into a writable bitmap, or you can save it to your isolated storage, or send it to a web service, or whatever you want to do. The phone call task is slightly different to the rest because it doesn't actually exit your application in the same way as the other ones do. It actually pops up in front. And unlike Windows Mobile 6, you can specify name as well as the phone number. So in this case, we've got John Smith and we've got his phone number, and we call show, and the user's prompted first, and it will not only show the name but also the number, so you can't try and fool somebody by putting call nice person and then give them a premium rate phone line or something. So if they select yes, I'm going to call them, then it opens up the regular dialer application, and they can actually use the keypad or put speakerphone on, those sort of things. But your application is still visible but kind of greyed out in the background. And whenever you end the call, you're straight back to where you left off. So the difference between sending emails and SMS messages, you had a number of properties Windows Mobile 6 that you could use with the compose dialog. In Windows Phone 7, for email, you have simply the to and the CC collections. You can specify a subject and a body, which is plain text. You don't have the ability to add attachments to that or access the BCC field. With SMS messages, it's even simpler. You just have to and body, and there's no support again for attaching a picture, so you can't create an MMS message. There are some additional tasks which are only in Windows Phone 7. So there are those around the marketplace. So you can look at a product detail. So as long as you have the product ID, so you could, for example, have a link that went through to another product that was related to the one they're currently running, saying, why not try this? And then you could point them at the details to that product. You could go to the hub, which basically just takes them to the outer marketplace hub. There's the option of actually going to the reviews page, and that actually opens up the page for the application that's currently running. So it provides a very quick way of getting your users to provide feedback on your application. And the last one there is the ability to search the marketplace, and you can add in any phrase that you want to there to search for. So you could enter your company name if you wanted to do a list of, here are my other products, or you could search for anything you want, really. There are a number of tasks. There's a controller for the media player so that you can launch media files and have the play and pause buttons available to the user. And the only interaction with the PIM controls on the device is the save email address and save phone number tasks. And again, you don't really have full access to any of the contacts, but you can add an email address or phone number, and basically the user will then decide whether they attach them to an existing contact or whether it creates a new record for you. We've also got a search task which you can pass any string into, and that basically does a Bing search, which will load up full screen. And so you could provide, if you're doing some kind of location-based service, you could actually pass an address or something through to Bing. And finally, there's the web browser task. This opens up a full-screen Internet Explorer view in a new window, whereas you could also use the web browser control within your forms if you wanted to. So we'll just have a look through some of those in action. One of the things you'll notice on the emulator is that there's actually no contact data in there. So if you try and use the select email address or select phone number, you don't get anything to choose from. But luckily, the emulator does support vCard format. So if you can download a vCard off the internet, so I've just used the web browser task and pointed at a URI where I'd put a simple vCard up. So the user just simply taps it, and then it will bring up a new contact record, which is populated with whatever was in that file. So this is a very quick way of actually getting some data onto the emulator. So if we're happy with that, we just tap the save button, and that's now in the contacts. Now, we can't actually access the contacts on the emulator because it's very locked down. You've basically got Internet Explorer or your applications, and that's it. But at least it means that now I can go into the select phone number, and I can see the record I've just put in there, so I can select. And then if there's multiple phone numbers or multiple email addresses, you then have to choose which one you want. So I can just check his home number, and you'll see back in the application I've now populated a text box with the number that was chosen. So I can then run the phone call task, which I've got that in, and then that'll pop up the dialer user interface, and then it started a phone call. Obviously it's on a fake network, so it's not doing anything. So the select email address basically works in the same way, but you can't send email on the emulator. It will just complain that there's no account set up. So if we look at another one here, the camera capture task, for example, there is a basic kind of camera driver built in, but it just sort of flickers and does little black boxes and white backgrounds. So it comes up with something pretty crappy like that, but you can accept it. And then in your application, you've got back that detail on the file name, which here is something quite cryptic. So it's applications data, and then a GUID, which is specific to the application, and then there's a file name at the end of it, but it's obviously too long to fit on there. But also, by using the stream, we can actually take that image, put it into a writable bitmap, and then assign it to the UI. So that's the kind of fake image that was taken just now on the camera. So for the next section, we're going to look at things that happen outside of the device, because obviously those have all been specific to the UI of the application. The first of these is location. Now, in Windows Mobile 6, you had the GPS API, which was there in native code, and there was a sample to do it in managed code, but it wasn't really supported. So in Windows Phone 7, there's actually the system device location namespace, and that matches the full .NET 4 framework. So it's a consistent way of doing location lookups, and it's not specific to GPS, but it will use GPS on the device if it's available, and it also wraps in cell triangulation and Wi-Fi as well. You don't get, like the old GPS API, you don't get any of the satellite information, so you don't know your fix was based on 4 satellites, 5 satellites, or whatever. So what you really need to do is to check the horizontal accuracy of the return data. And that gives you a value in meters. So it gives you an idea of whether you're looking at a whole cell site or whether you're looking at a couple of meters for a really good GPS fix. There's also a class in there called the civic address resolver, which from any GPS coordinates should bring back a civic address, so a street address. But at the moment, and the current version, it's not actually implemented. So although it's there and it matches the desktop version, it doesn't actually do anything. It will always return an unknown address. So another aspect of kind of interacting with the outside world is the sound. So on Windows Mobile 6, if you're using Compact Framework 3.5, you have the sound player control class, sorry. So basically you could pass in a file name or a stream and it would play back wave audio, and you could play synchronous, asynchronous, or continuously loop sample. If you're using Compact Framework 2, you could access it by invoking play sound, which is a native API. On Windows Phone 7, there's actually a class which is specific to the XNA framework, but you can actually use it within a Silverlight application as well. So that's called Sound Effect. And again, it plays wave audio. You pass in either a stream of bytes or a byte array, and it's always an asynchronous playback. You can do other things with it, like change the pitch up and down, change the stereo position, but obviously that only really makes a difference if you're using a headset. And also you can change the volume of individual sound effects as well. One of the good things about it, though, is it actually has kind of a mixer built into it. So if you're actually playing lots of sound files in different places, it actually mixes them together, so it doesn't abruptly cut off whatever was playing. So you can create some quite complex effects using that, and obviously that's very useful in games as well. The only thing you have to be aware of is you have to call framework dispatcher update at some point in your application before you first call sound effect. That's kind of a utility method that's in the XNA framework. So basically I found if you just call it within the constructor of your page, you're then good to go. You only have to call it once and then you can use the sound effect. So one of the things that you had available on Windows Mobile was the system state properties. So you could actually check if there was a network available, and if so, what type. So is it GPRS, is it a Wi-Fi connection, or is it docked to the computer? So in Silverlight, you have a standard method of detecting just whether there is a network connection or not. That's in the system.net.network information namespace, and it's the network change class as a static event on it, which you can hook up to. And that's called network address change. Although it indicates that the address has changed, you actually have no access to whatever the current IP address is of the phone, but it at least allows you to know that something's changed on the network. So then you can actually query, there's a static property, method of get is network available. So that will basically decide if there is any network connection currently available. So it doesn't matter whether it's docked to the computer, whether it's on Wi-Fi, you'll get a true or false answer. Next, you get the type of network, because this can make a difference to the kind of bandwidth available. And this is actually specific to Windows Phone. It's not part of Silverlight in general. So in the Microsoft Phone.net.network information namespace, there is the network interface class, which has a property on it. And this will return a number of possible values. So if you're on a mobile network, it'll contain mobile broadband, CDMA, or GSM. It could contain none, obviously, if there's no network. Or it can contain wireless 802.11 if you're on a wireless network, or it could also contain Ethernet, which is what you get when your device is docked to the PC. The emulator always returns wireless 802.11, regardless of however your computer is connected. And I think it actually remains that way if your computer is actually disconnected from the network. So what are some limitations in networking? You don't really have much access to what's going on, so you can't tell what your IP address is, you can't do DNS lookups and that sort of thing. And you can't actually determine what mobile network you're on. So if you had an application that for some reason needed to know whether you're on Vodafone or whatever, you have no access to that yourself. Another thing which is quite annoying is you can't tell whether you're roaming or not. The user has the option of enabling or disabling data when they're roaming, but you'll never know whether that was set or not. You'll either get a network, in which case you'll think, oh, hurrah, I have a network, and you might start downloading megabytes of stuff, or the user will have disabled it and you just won't get a network connection of any kind whatsoever. And finally, it's not really a programming issue, but the Wi-Fi support on the phone only will connect to infrastructure networks. It won't allow ad hoc connections between like a laptop or another piece of machinery. So another difference really with how the networking works under Silverlight is because it was designed originally to run within a web browser, is all the requests that you create are asynchronous, so they'll get run in a separate thread and then you'll get notified back as things are happening. This is different, obviously, to Compact Framework, where you had the choice of running them in your own background thread or running them synchronously on the UI, which obviously you wouldn't want to do, or asynchronously. And so if you had code that did it differently, you'll have to obviously change that as you move across. So you have various methods of using HTTP networking. So you have the HTTP web request, which is obviously the lowest level you have available, so you can do any kind of raw web lookup with that. The web client class kind of simplifies things. You can download strings and things quite easily. And when it returns, the event that returns from a download string, for example, always happens on the UI thread as well. So it's quite handy to do simple things and then update your UI just from when that event has got called. And finally, if you do web services, so if you add a service reference and it creates a web service proxy, all of the methods on that web service will be in the asynchronous only versions. So hopefully if the network's working okay on the emulator, we can show that running. So just click the button here.
Hello, Auckland. I'm the Bing Translation Web Service.
So what the application's done is it's gone off and made a web request to the Bing translation website. I'll just find the code. So it passes through an app ID, which is unique to your application, and a small piece of text and whatever language that text is in. So it goes off and creates a web request. And then when it comes back, the response stream actually contains the raw WAV data of the audio. So all we do then is we assign that to a sound effect and call play. And that's it. We close the request, and the sound effect then plays asynchronously. So all of that can happen while things are going on in the UI. You can actually have other sounds kicked off at the same time, as we said, and they're kind of mixed together. And if it returns back with an error, you can obviously handle that as well in the response. But you don't have to wait for it. You're just hooking up an event handler rather than waiting for some kind of timeout or something to go wrong. So what about if you've used some other kind of networking technology? So for example, if you have a server that you don't have any control over and you're sending FTP data to it or some other kind of TCP sockets, any kind of custom protocol you've got going on, you're pretty stuffed if you want to try and use that directly, because Silverlight 3 will only support HTTP networking. So what you can do is, obviously, if you've got control over the server, you can actually create a web service instead, and that's quite easy to use. But if not, you can actually add in kind of an intermediary somewhere in the cloud, which will talk in your old protocol to the server and then actually expose a nice web service for your phone to use. So depending on whether or not this is the back end that you've got control over, or if it's someone else's system and you still want to interact with it, the workaround is to place your service somewhere else and then run a WCF web service to the phone. Okay, so here are a few useful resources based on the session. So I've got a blog there. I have posts on it related to Compact Framework and also Windows Phone development. And also I'll make sure I post a link to the source code on there as well. If you haven't already been to some of the sessions and done the sort of background in Silverlight, there's a series of 12 training sessions available online, the Jumpstart training. So if you look at that blog post there, there's a list to all of them and it shows you what topics are available, and that's a really good way to get started on Windows Phone 7. And lastly on the page there, the design resources, because we talked about creating your own pop-ups and other UI things. Basically, there's a document there and actually some Photoshop templates as well, which show you kind of what look you should be going for to match the sort of system look and feel. So most of the related sessions here have actually already happened. So if you missed 304, 305 or 301, they were earlier today, but they'll be available online if you want to catch up on those. And then tomorrow there's session 401, which is phone zero to phone hero, which is a kind of a walkthrough from nothing to a full application. So that's everything I've got in the session, but if you want to come up and ask me questions, I'll hang around here for a little bit longer. But thanks for sticking it out. Thank you.